The PSpice Advanced Analysis Parametric Plotter lets you sweep multiple parameters, including device parameters, and display the results in a spreadsheet format or graphically using the PSpice probe tool. In our design, we'd like to analyze the effects of the values of the R3 resistor and the R7 resistor on our design for the 3 dB cutoff frequency at the output as well as the gain at the output. We'll use the parametric plotter to do this, and to use the parametric plotter we must first set up a traditional PSpice simulation and add measurements for our 3 dB cutoff frequency and our gain. We've already set up our simulation profile, which we can view by selecting PSpice, Edit Simulation Profile. Our simulation will run an AC sweep of our voltage source starting at 1 MHz and going up to 600 MHz logarithmically with 100 points per decade. We'll run our simulation, and when the simulation completes, the probe window will open. We'll verify that our simulation ran correctly by adding a plot of our voltage at our output in decibels, by selecting Trace, Add Trace. We'll select our decibel function in the Functions and Macro side of the Add Trace form and then scroll down and insert our vote net and click OK. And our trace is added to the probe window. The measurements we'd like to evaluate in the parametric plotter are the 3 dB cutoff frequency and the gain at our voltage output, so we'll add those measurements to our probe window. We'll select Trace, Evaluate Measurement. We'll select the cutoff low pass 3 dB function and insert our vote net. Our measurement is added to the measurement results spreadsheet, and we can see that our 3 dB cutoff frequency is 186.5 MHz. Again, we'll select Trace, Evaluate Measurement, and we'll use the max function to measure our gain at the output. We'll be doing it in dB, so inside of our max function we'll use the dB function and then insert our vote net, and again in the measurements results spreadsheet we see that our gain is about 18. Now that we've run our standard simulation and added our measurements, we're ready to invoke the parametric plotter. We'll go back to Capture and select PSpice, Advanced Analysis, Parametric Plot from the Capture text menu to invoke the parametric plotter. In the parametric plotter we need to import the parameters that we'd like to sweep, and we decided that we'd like to sweep the value of our R3 resistor and the value of the R7 resistor. So we'll select in the Sweep Parameters spreadsheet, and the different parameters that we can sweep from our schematic are displayed. We'll select our R3 resistor and its value, and in the Sweep Values cell we could set our sweep settings. We could sweep either by discrete values, linearly, or logarithmically. When we select linear, the sweep settings spreadsheet uses a start value that's 1/10 of the value from our schematic and an end value that's 10 times the value from our schematic, and it'll sweep 10 different values. We'll click OK in the sweep settings form, and the value is inserted into our sweep parameters spreadsheet. Similarly, for our 7 we'll select the sweep values cell and we'll sweep that linearly as well. We can adjust our start value if we choose to, and if we change the start value to 69.3 ohms instead of the default value, we can see that will only require 8 steps rather than the default 10 steps, and we'll click OK in the sweep settings form to insert that value into our sweep parameters form. Next, we need to import the measurements that we're interested in. We'll select the top row of the measurement spreadsheet and the measurements that we created in the probe window. Our 3 dB cutoff frequency and our gain measurement are displayed for us to import. We'll select them both and click OK to import out 2 measurements. We're now ready to run the parametric plotter. Notice that in the output window it indicates the parametric plotter is going to need to run 80 different simulations. The value of our R7 resistor is going to have 8 separate values, and the value of the R3 resistor will have 10 different steps to give us our 80 simulations. Let's select Run in the parametric plotter and our simulations start. When all the simulations are complete, the results are displayed. The results are displayed in a spreadsheet format, and there's a column for each of our parameters that were being swept. Our R7 resistor started with a value of 69.3 ohms, and R3 was swept at its 10 values while R7 was held at 69.3 ohms, and as the value of R3 changed, our low-pass cutoff frequency and our gain is displayed in their respective columns. As we scroll down, we see that the value of R7 steps through its 8 different values, with R3 being set to its 10 values each time. And the cutoff frequency and the gain are displayed for all the different 80 simulations. We can sort by any of the columns by double-clicking on the column to sort them in either ascending or descending order. If we sort our cutoff frequency in descending order, we can easily scroll down and find a combination of values for R7 and R3 that allows us to meet a minimum low cutoff frequency of at least 200 MHz and a gain of at least 10 decibels, and we can see the value of R7 of 69.3 ohms with R3 being almost 9K ohms allows us to meet that criteria. We can also view this information as plots. To view plots, we select the Plot Information folder tab in the Parametric plotter. We then select in the Plot Information spreadsheet to add a new plot. If we had multiple simulation profiles, we'd be able to select the simulation profile we'd like to use. We'll select our AC simulation profile that we simulated in PSpice, and we'll select the next button where we need to set up the parameter along our x-axis. In the pull-down field, we can select either of our parameters, the value of R7 or the value of R3, or have one of our measurements along the x-axis. We'll graph the value of R3 along our x-axis, and along the y-axis will be our 3 dB cutoff frequency. The parameter we varied for each of the plots that are displayed will be the value of our R7 resistor, and we'll pick Finish in the Plot Information wizard. If we select the row for our new plot with our right mouse button, we can select the Display Plot option to have this plot displayed in the probe window. So we defined in the plot window, probe window showing the sweep of the value of our R3 resistor along the x-axis. Along the y-axis is our 3 dB cutoff frequency measurement, and then each of the plots represents the different values for the R7 resistor. If we select our green plot and right mouse button on the plot and select the Trace Information option, we can see that the green plot represents the value of 69.3 ohms for our R7 resistor. Similarly, if we are to select the red plot and select Trace Information, we can see that that represents the 102.3 ohm value for our R7 resistor, and similarly, we can see how the plot changes as the value of R7 increases. So for this plot, our x-axis represented the value of one of our resistors and the y-axis represented one of our measurements. Each of the different plots was the different values for our R7 resistor. We can also take our two measurements and place them both on the axis so that one axis is our 3 dB cutoff frequency and the other axis is our gain, and we'll hold the value of one of our resistors constant while the other value is swept. We'll go back to the parametric plot window and we'll click in the Plot Information spreadsheet to add another plot. We'll select our AC sweep profile, and for these plots we'll put our low pass cutoff frequency on the x-axis. For the y-axis, we'll select our other measurement, our gain along the y-axis. We can then sweep either the value of the R7 resistor or the R3 resistor. We'll sweep the value of our R7 resistor, and we'll have to hold the value of the R3 resistor at a constant value. We'll right mouse button on the 5610 value, and we'll select the right option to lock that resistor at 5610 ohms, and we'll add that plot. If we right mouse button on our new row in our plot information spreadsheet, we can display our plot information. For these plots, our 3 dB cutoff frequency is along the x-axis and our gain in is along the y-axis, while the value of the R3 resistor was held at 5.6 k ohms. From this plot we can easily find the simulations that gave us a gain of at least 10 with a cutoff frequency of at least 200 MHz. If we were to right mouse button on one of the points on the graph, we could select the Trace Information option from the pull-down menu and see the value for R7 that gave us that result. Our different plots are kept in the Parametric plotter in different folder tabs to make it easy to switch back and forth between your different plot views. We can also go back to the Parametric plotter and use the Results folder tab to view the spreadsheet of all of our results as well. The Parametric plotter allowed us to sweep multiple parameters in our design, including device parameters, and display the results in a spreadsheet format, as well as display them graphically in the probe window.